Alright, today we are learning about arithmetic sequences. This is lesson 6C. So this would be the first day that you will not have me. So on Monday we should have done lesson 6B. And today we're doing lesson 6C. It should be Wednesday. Okay, so guess we'll just go straight to the worked example. Well, they have a rule. We'll go ahead and go with that. So this is in your formula booklet. And you're going to become very familiar with this rule. UN, that's the nth term. UN is the nth term equals U1, the first term, plus N, that's the term number. So if it's like the third term, N would be 3. Minus 1 times D, which is the common difference. I will label all of this for you. So this is called the nth term. Meaning nth could be fourth or fifth or sixth or third. So it's nth, but it could be third to RD. But anyway, it's most numbers end in TH. Fourth term, fifth term, sixth term, seventh term, and that kind of thing. So the nth term, where N is your term number. This is your first term. N is your term number. And D is your common difference. That is what you are adding each time. If it looks like you are subtracting a number each time, then you're really adding a negative number. So your D would be a negative number. So really with arithmetic sequences, you're adding some number each time. So even if it looks like you're subtracting, you're really still adding. So let's go ahead and do worked example 6.6. That is on page 138. It says, what is the fourth term of an arithmetic sequence? Right now, arithmetic sequence is the only kind of sequence you know about, but later on that's going to become important. With U1 equals 300 and common difference equals -5. Well, the book kind of did it the long way. They just did first term, then second term, third term, fourth term. And you can certainly do that. You don't really need the rule for this. First term is 300. The common difference is -5, so you are basically adding -5 each time. So 300 plus -5 is the second term. And third term is, so this is 295. So the third term would be 295 plus -5, which is 290, and then fourth term is 290 plus -5. You don't need to write plus -5, it's just -5. I'm just doing that just so you can see that you really are adding something each time. And this winds up being 285. So therefore, the fourth term, which we're going to call U4, the fourth term is U4, is equal to 285. And we could do that kind of by hand, kind of a long way without a formula, because it's only the fourth term. And the problem gets to be when you have to find like the 15th term. If you can imagine, this will get kind of tedious after a while. So that's where the formula comes into play. We're going to do that. Worked example 6.7 wants to know the 100th term. Wow, that's a doozy, isn't it? Definitely don't want to do that process over and over again 100 times. So that's why the formula is really useful and handy. And you'll find out later in the chapter that this formula is useful for a lot of other things as well. So hold on tight, you're going to learn some really cool things. Make sure you pay attention and do all your homework, and make sure you ask me questions if you have questions, because the rest of the chapters because we're going to rely on previous knowledge within the chapter, and if you don't keep up with your studies, you're going to have a hard time. So it says the fifth term, U5, we start taking shorthand, U5 is 7, and the eighth term is 16. What is the 100th term? So U100 is equal to question mark. Okay, well, they just jump right into it. We're not actually really using the formula. We're actually going to do simultaneous equations, sort of, because they don't give us the common difference. Now, we could find the common difference. Actually, there's a process that Logan actually discovered. I never knew it before. It turns out the mark scheme uses this a lot to find the common difference when you know two random terms, like U5 and U8. They're not spaced that far apart, so it wouldn't be too difficult to figure that out. But the formula is, to find the common difference, you're going to subtract these two numbers, and then put that over and subtract these two numbers. I don't know how Logan figured this out, but he did. It just never occurred to me. The book does it in a different way. It actually does simultaneous equations, and I'll show you how to do that in just a minute. But it's interesting. You actually don't need to do what all the book did. You actually just need to do the short way. So Logan would ask me, can I just do the short way? Do I have to do it the long way? And I'm like, I don't know. But then when I looked at the mark scheme actually had this as one of the methods. So I'm like, oh, okay, I guess you can use that method. The way the book did it was they did simultaneous equations using the formula. So it was UN equals U1 plus N minus 1 times the common difference. And then plug into the formula twice. So U5 is 7. So 7 equals U1, we don't know, plus N is 5. And we don't know the common difference. And then 16, so U8, the eighth term is 16, that's why that goes there. The term itself goes there. And then it's U1, we don't know that. The eighth term, so 8 minus 1 times the common difference. When we have two unknowns, we have to use simultaneous equations. So what you end up doing is probably I'm going to distribute this into there and this into there. So, like this. 7 equals U1 plus 5D minus D. Well, I have to do that. I just realized that. It's really, that's 4. 5 minus 1 is 4 plus 4D. And here it's 16 equals U1 plus 7D. There we go. Now, we have two equations and two unknowns. We're going to for this one I'm just going to use elimination. So you're going to change the signs of either the top or the bottom. It doesn't matter which. And then add straight down. These will eliminate. That's what you want. So it winds up being negative 9 equals negative 3D. D equals 3. There we go. So we have the common difference. We still don't know the first term. We actually need that as well to find U100. We also need the first term. But that's not difficult because now that we have these two equations, we can plug the common difference either into this one right here or this one right here and find out easily the U1. Let's see. I'm going to use the first one. 7 equals U1 plus 4 times 3 because it's 4 times D and D is 3. So what ends up being U1 is equal to negative 5. There we go. Now that we know U1 and we know the common difference, now we can go ahead and find our 100th term. So U100 equals U1, the formula states U1 first, so it's negative 5, plus parentheses n, which is 100, minus 1, times the common difference, which is 3. And this is all the formula from the first page. So U100, at this point you just simplify. 99 times 3 minus 5 winds up being 292. If you don't know that, you can just plug that into your calculator. So therefore, the 100th term is 292. So there you go. And using Logan's way to find the common difference, some of you might be asking, well, that's great, his method gets you the common difference, but it doesn't help you find U1. Well, that's when you would go ahead and you would just set up one of these two equations. It doesn't matter which one. You would do one of those, and you would just follow this process right down here that we did. You would do that once you know the common difference. So basically, by using Logan's method, you would essentially be skipping really all of this stuff right here. It's not too difficult. It's not a difficult thing to do, but anyway, this is definitely a shorter way. You could do this in your head. If you needed to just find the common difference, you could easily just do this method in your head very quickly. So you subtract these two and divide that by the difference of these two. It's very simple. And that is it for that particular example. There's one more example in this lesson, and it's for example 6.8. This is actually an easier one. So let's go ahead and do that. It's on page 140, and it says an arithmetic progression, so that's just an arithmetic sequence, has first term, so first term is U1, first term is 5, and common difference is 7. What is the term number corresponding to the value 355? So in other words, UN, the nth term, is 355, and we have to find that. So always start with the formula. I didn't really write the formula out a lot in the last example because I knew I didn't have a lot of space for that. But the formula is UN equals U1 plus n minus 1 times the common difference. So we know UN is 355, so we're going to put that right here in place of UN. U1 is 5 plus n is what we're trying to find. N is the term number. That is what we're trying to find, so you can't plug anything in there. Common difference is 7. Now you're going to distribute into the parentheses, and you get essentially 350 equals 7n minus 7. 343 equals 7n. And when you do that division, you get n equals 51. Therefore, here's the question. The number 355 is the 51st term. And that is it. That's all for the lesson. Let me bring the mark scheme. Let me go pick that up. Not a mark scheme. Okay, let's see. 60. So we're doing a lesson a day. Wow, that's quite ambitious. Anyway, I'm going to do, so 6C, exercise 6D will be due Thursday. I won't be at school to check it, so obviously, but you need to have it done, or at least as much of it done as you can. Just try to practice as much as you can, and then be ready to move on to 6D on Thursday. Don't want to get behind. None of this is very difficult. But let's keep up though. And then we'll do 6D on Thursday. And Friday is supposed to be 6E. I know you technically don't have class that day, but I'm going to go ahead and do that lesson anyway for you. That was a mistake, I guess, on the pacing calendar. What does it say? 6E, that was supposed to be Friday. That was a mistake on the pacing calendar when I did that. So, anyway. But, that's going to be the plan. I'll have to go ahead and do 6E, but I don't know what's supposed to be. I keep getting that one. That's what's going to go the pacing charts for my hand. 6F will be after the break. So, we'll start that somehow, figure out when to do 6E. 6E is geometric sequences. Geometric sequences are pretty simple. It shouldn't be too much of a problem. But anyway, so I will see you there. If you have any questions on exercise 6C, you're welcome to send me an email. I can work a problem for you, send it to you just like normal. Or I should have already sent you a link to my Skype address so you can Skype me if I'm on. I'm not always on. I won't always be on, but if I am, and if I'm not on and you need help, then you can just send me an email and I can tell you when I'm going to be on Skype. So if you need to just ask a quick question, have me explain something to you. So anyway, with that, I will say goodbye for this video, and I will see you in the next video. Good luck with the homework.